Welcome to qnawire.
In this question, we have to calculate what is the energy difference between this quantum state and this quantum state. Well, there are several contributions to the energy of a given quantum state of an atom. So, one contribution comes from the principal quantum number, but it is the same for both states. Another contribution comes from the orbital and quantum number, which is again the same for both atoms. Another one for ml, the magnetic quantum number, which is again the same. And then we have the only contribution which is not the same for both atoms, which is the contribution coming from the spin. Then E1 minus E2 is just the difference between this contribution that comes from the spin. Remember that this contribution is given by minus G mu B times the external magnetic field times the spin quantum number. This is for state number 1 and the same for state number 2 with exception to the spin quantum number. Therefore, delta E, we can set this to be equals to E1 minus E2 is equals to minus G mu B times B multiplied by ms of state 1 minus ms of state number 2. Then we get the following. Delta E is equals to minus G mu B times B. ms1 is equals to minus 1/2. Then minus plus 1/2, which is minus 1/2 again. Minus 1/2 is equals to 1, and we get delta E as being equals to, well, this is equals to minus 1, so the signals cancel out, and we have G mu B times B. Using the values that were given in the problem for the magnetic field, and using the known values for G and mu B, we got 2.0023 times 9.27 times 10 to minus 24 times 2.5. This is the energy difference, but this will come out in joules. So if we divide by the electron charge, we can convert it from joules to electron volts, and we will do that in order to get 2.0023 times 9.27 times 10 to minus 24 times 2.5 divided by 1.6 times 10 to the minus 19. And this gives us approximately 2.9 times 10 to the minus 4 electron volts.